Hi everyone, and welcome to another video lesson. We are getting close to the end of our chemistry unit, and you guys have been doing a great job of keeping up with these videos. So just keep swimming. We're getting through chemistry. We're almost there. Today we're going to be talking about types of reactions. So last week we were focused on how to write out reactions as chemical equations in both word form and balanced equation form. So now we're going to look at what different types of reactions we actually have and how we can classify those based on their reactants and products. So we're going to start with a little game. So you should have this on your note. Oh yeah, if you haven't checked out the note that goes with this, pause and just go to Google Classroom to find that. But at the top of that sheet, there should be this list of chemical equations. And so we're going to I want you guys to pause the video in a second, and you're going to try to look for similarities between these reactions, and you're going to try to sort them into 4 groups. So you could do that by just using like a color code, if you have something handy, or a little symbol or something on your sheet to write beside these reactions. So try to sort them into 4 groups that are similar. So pause now and try that. Okay, so hopefully you gave that a try. I'm gonna go through, and if we look at the number of reactants versus the number of products, we start to see these different patterns emerge. And so here's how I color coded them. Again, you can pause if you want to write that down on yours, or just make a little note of it, or take a picture or whatever. But here's how I sorted them. So I think it will be easier. I'm going to group all the reds together, all the blues together, purples and brown. And I think that'll make it a little bit more obvious as to what the similarity might be. So let's see it like that. Okay, so group 1. Everything on group 1, here I've got 2 reactants, 1 product. 2 reactants, 1 product. 2 reactants, 1 product. So I'm going to say the rule for this group is that we only end up with 1 product. If I look at all the blues that are grouped together, I've got 1 reactant, 2 products. 1 reactant, 2 products. 1 reactant, 2 products. So this is almost like the opposite of our group 1. This time we only have 1 reactant. Okay, if we look at the purple group, 2 reactants, 2 products. 2 reactants, 2 products. That rule is no longer applying to these ones. Maybe let's look at the type of reactants and products that we have. So here I've got iron all by itself, and then copper sulfate. And here I have iron sulfate and copper all by itself. Chlorine's all by itself, and then it comes in and it bumps out the I, and now I's all by itself. Sodium's all by itself. So it looks like we're starting with something that's all by itself, which is a single element, and a compound, and then it switches. That element seems to come into the compound, as you can see here, and it bumps something else out to be on its own. So we have 1 element and 1 compound on each side. Group 4. Okay, so we've got 2 reactants and 2 products. 2 reactants, 2 products. It looks like I've got a compound here. I've got potassium iodide. I've got another compound here. I've got lead 2 nitrate. Still 2 compounds. So this one looks like there's 2 compounds on each side. So you might have found some different similarities and differences, and that's totally awesome. We are going to use these as a bit of a guide for today, and we're going to come back to these ideas of what's similar and different between the reactants and products. So there's 6 types of reactions that we're going to talk about today. The first is called synthesis. The second is decomposition, single replacement, double displacement, combustion, and neutralization. And so you can see those colors look familiar. All of a sudden, I'm going to add a name to those rules that we just looked at. So let's look at the first one. So the first one was called synthesis, and this is when two or more reactants combine to form one new product. So we've got two things being combined to form one big thing at the end. And that's what synthesis, that's what that word means. We're synthesizing something. It means we're building something, or we're putting something together. So we're going to be using a Riverdale analogy, and I haven't actually seen this show, so this will not be accurate to the plot by any means, but I figured this might help things make a little bit more sense. So let's look at this. We've got Archie will be A, Betty will be B, and if they come together to form a couple, then they have just shown us a synthesis reaction. And if we look at the examples back from our game, so all of these reactions, like we pointed out before, they all start with multiple reactants, but they all end with only one product. So that would be the kind of look for, that would be what you'd want to keep your eye out for when you're trying to figure out which type of reaction you have. If it has only one product, then that's going to be a synthesis reaction. Okay, next up is decomposition, and this is when one reactant breaks down or decomposes to form multiple products. So we've got this opposite idea of synthesis. We're breaking something down instead of building it and putting it together. So here we're starting with only one product or one reactant, and then we're going to be breaking up into different parts. So this is the opposite. We have our couple and they break up. They're two separate things now. And the examples from the game, we can see the exact same thing. So you're looking for, if there's only one reactant that you're starting with and then it's breaking into pieces, that is decomposition. Okay, single displacement. This is when one element displaces another in a compound. So for example, if this, and these aren't real elements or compounds, by the way, these are just random letters to kind of show what's happening. But if we have a single element, something that's all on its own, and we have a compound, that single element is going to bump out something in the compound, and then it's left on its own over here. So that's why it's single displacement, because a single element is displacing another element. So if we were to look at that, we're adding Jughead into the mix here. So if Jughead was all on its own, he comes into this scenario and he steals Betty away, and now Archie's left on his own. So our examples from the game, if you look at that, we pointed out that on each side we've got this single element and a compound, and then that element has taken the place of another. So in our copper sulfide compound here, iron has come in and has taken copper's place, and now copper's on its own. So you're looking for an element starting on its own on the reactant side and a different element ending up on its own on the product side. Double displacement. This is when we have two elements in different compounds that swap places, and it forms two new compounds. So we've got, instead of just one single element coming in and displacing another, we've got two actually switching places. So we're starting with two compounds and we're ending with two compounds, but they're different. We've had at least two elements switch places. So let's take a look. If we started with Veronica and Jughead and Archie and Betty, and they switched partners, so we're ending up with Betty and Jughead and Veronica and Archie. So we can see that that swap has happened. We started with two couples, we end with two couples, but they're with opposite partners. And so the example from the game, we can see that that is exactly what happens. We've got potassium that's coupled up with iodine, lead that's coupled up with nitrate, and here we have the opposite. The potassium has now paired up with the nitrate, and the lead is now paired up with the iodine. So you're looking for two compounds on either side that have just switched places. So then the last two are a little bit different. They are kind of the special types of reactions. Combustion is when a fuel, often a hydrocarbon, and a hydrocarbon is just different compounds that are made up of carbon and hydrogen. So when we have a hydrocarbon burning, and anytime we have something burning, it means that oxygen's being added in. So whenever it burns, it's going to form carbon dioxide and water. So here we're less concerned with how many reactants and how many products we have. We're more concerned with what those reactants and products are. Meaning that if you see oxygen on the reactant side and carbon dioxide and water on the product side, that is a combustion reaction. And so some examples of that would be, and we haven't seen those before, I didn't include these in the game. So for example, this first one, CH4, so that would be a hydrocarbon. We're adding an oxygen and we're producing carbon dioxide and water. Here we've got a crazy complicated hydrocarbon, but still we can see that we're mostly made up of just carbon and hydrogen. So that's a big hydrocarbon, adding in oxygen and still ending up with water and carbon dioxide. So as soon as you see those reactants and products, that's what's going to tell you that it's a combustion reaction. And you'll usually figure it out maybe because it doesn't follow the rules of our other 4 reactions that we've looked at. If you kind of go through process of elimination, you'll see that it doesn't quite fit into any of those other categories. So if that's the case, if you find yourself looking at something that doesn't really fit into those categories, check for oxygen and carbon dioxide and water, because if they're there, then you know you have combustion. Now we also have something called incomplete combustion, and this is what happens when there isn't enough oxygen to burn all of the fuel. So there could be other products formed, such as carbon monoxide and soot. And so I'm just going to jump back. What that would look like is on this product side, we would still have carbon dioxide and water, but we might also have carbon monoxide or just carbon on itself. So you might see some additional products. That doesn't mean that it's not combustion. It's still combustion as long as you have these 3 things. But sometimes we have incomplete combustion where we might have extra products. Okay, and then our last one is called neutralization. And this is when an acid and a base combine to form water and salt. And I'm not going to go into too much detail here because our last lesson later this week is going to be on acids and bases and neutralization. So we'll leave that one for later. So I've attached a practice sheet to the Google Classroom with the solutions as well, so you can check your answers as you go. Note that there will not be any neutralization reactions on there because we haven't really gone into detail about that one yet. I wouldn't expect you to know how to pick it out. So for the practice sheet, there's just going to be the first 5 reaction types that we talked about. All right, have a great day.